Next point we are going to see effective atomic number, that is EAN rule. Now the scientist Sidwicks, who proposed an empirical rule known as effective atomic number rule. Now here En, that is effective atomic number, is equal to total number of electrons around the central metal ion in the complex. That is, in the complex, the number of total electrons surrounded by the central metal ion is nothing but effective atomic number of the central metal ion of the complex. Now here En rule states that a metal ion continues to accept electron pairs till it attains the electronic configuration of next noble gas. That is, this En equal to, or effective atomic number equal to 18, that is argon, or it is 36 for krypton, then 54, that is xenon, or 86, that is radon. Then En rule is obeyed. Now we are going to see the formula of En value. Now the formula for or En value can be calculated by using this formula. En is equal to number of electrons of metal ion, that is here total number of electrons present in metal ion plus total number of electrons donated by the ligands. Now it can be calculated like this, that is atomic number of metal ion, which is denoted by Z, then number of electrons lost by metal to form an ion, that is this metal from its atomic state, when it is converted into ionic state, then how many number of electrons are lost, then consider this as X, and plus number of electrons donated by ligands, that is Y. Now therefore En value is equal to Z minus X plus Y, Z minus X plus Y. Now we are going to calculate the En value of some complexes. First example, CONH3 6 times 3 plus. Now in this example, first we have to calculate the oxidation state of central metal ion, and we must know what is the atomic number of this cobalt. Now here atomic number of cobalt, that is Z of cobalt, is equal to 27. Then oxidation state of cobalt in this complex ion is plus 3, that is X is equal to plus 3, that is oxidation state of cobalt is plus 3, and number of electrons donated by ligands, that is Y, is equal to, now here there are 6 NH3 group and each NH3 group donate 2 electrons, therefore it becomes 12. 6 multiplied by 2 is equal to 12. Therefore EAN is equal to, we know the formula, Z minus X plus Y, where Z is atomic number of cobalt, X is the oxidation state of this cobalt, that is when this cobalt is converted into plus 3, it donate 3 electrons plus number of electrons donated by ligands. Therefore it becomes 27 minus 3 plus 12. Then it becomes 36. This atomic number is of krypton, and therefore this CONH3 6 times 3 plus complex obey the EAN rule. Now we are going to see second example. Now here this is second example. Now atomic number of chromium Z is equal to 24. Now the oxidation state of chromium in this complex is 0, that is here value of X is equal to 0, and number of electrons donated by ligands, that is carbonyl group, are 6 multiplied by 2, that is each ligand donate one pair of electron, therefore y is equal to 12. Therefore En rule is or En value is equal to, the formula is z minus x plus y. Now z is equal to 24, now x is 0 and here y is equal to 12, therefore it becomes 36. It is nothing but the atomic number of krypton, and therefore this complex ion obey the En rule. Now third example, FeCN6 4 minus. Now here the atomic number of ion Z is equal to 26. Oxidation state of ion is +2. Now here this +2 oxidation state of ion is obtained by gaining 2 electrons. Therefore X is equal to +2. Now next one, Y, that is number of electrons donated by this cyanide. Now here there are 6 cyanide and each cyanide donate 2 electrons, therefore it becomes 12. Therefore En is equal to Z minus X plus Y. Here Z is 26 and number of electrons donated by this metal ion to form +2 oxidation state is 2. Therefore it becomes 26 minus 2 plus 12. Then it becomes 36. And here this is also atomic number of krypton, and therefore this complex, that is FeCN6 4 minus complex ion, also obey the En rule. In this way En value is calculated. Next point. Now here certain coordination compound, however, do not obey the En rule. Now here we are going to calculate the En value of these coordination compounds. Now it is FeCN6 3 minus. Now here atomic number of ion, that is Z is equal to 26. Now here oxidation state of ion in this complex is +3. Therefore when this Fe3 plus ion is formed, then the number of electrons donated by this Fe3 plus or Fe, then it becomes +3. Now the number of electrons donated by ligands, that is Y, is equal to, here there are 6 cyano group and each cyano group donates 2 electrons. Therefore it becomes 6 into 2, that is 12. Therefore En is equal to Z minus X plus Y, where Z is atomic number of ion, that is 26. Then here number of electrons donated by metal to form Fe3 plus ion, it becomes 3, and Y is equal to 12, that is number of electrons donated by ligands. Therefore here this value becomes 35, and it is not the atomic number of any noble gas, and therefore this complex do not obey En rule. Then second example. Now here the central metal ion is copper. Atomic number of copper is equal to Z is equal to 29. Now the oxidation state of copper in this complex is +2. That is here X is equal to +2 and Y, that is number of electrons donated by this ligand, are 4 into 2. That is there are 4 amine group and each ammonia donate 2 electrons, therefore it becomes 8. Then here En is equal to Z minus X plus Y. Now here value of Z is 29, X is equal to 2 and number of electrons donated by ligand is equal to 8. Now 8 minus 2, is equal to 6 and 6 plus 29 is equal to 35, and it is also not the atomic number of any noble gas, and therefore this complex does not obey the EN rule. In this way, there are some exceptional cases of coordination compound which do not obey the EN rule. Now, homework for you. Write the representation of following compounds: tricarbonato cobaltate 3 ion, second sodium hexacyanoferrate 3 ion, potassium hexacyanoferrate 2, then 4 number aqua chloro bis ethylene diamine cobalt 3, then next one is tetra aqua dichloro chromium 3 chloride, and last one is diamine dichloro platinum 2. Next question is, find out the EN of ZnNH3 4 times 2 plus and FeCN6 4 minus complex ion. Next question, do the following complexes follow the EN rule? First one is CrCO4, second is NiCO4, third is MnCO5, and last one is FeCO5. Next question is, write the formula for tetramine platinum 2 chloride. Next question is, what is the coordination number and oxidation state of metal ion in the complex PtNH3 3 times Cl5 minus? Classify following complexes as homoleptic and heteroleptic complex.